Hi guys, in this video we're going to be looking at patterns and functions. In example 1 it says, suppose you're making popcorn for a fundraiser. The relationship between the number of boxes of popcorn is the input and the number of bags of popcorn is the output. Use a table to write a function rule. So the first thing that we're going to do is we are going to find out what's happening. Now the input is what I'm putting into the equation that ends up changing the result. So in this case the result is the bags of popcorn that is resulting or ending up with. So this is my x and then this is my y. So our input is the number of boxes and the output is the number of bags. So the number of bags is 8 times the number of boxes. How did they get that? They saw that 1 times 8 ended up giving them the answer to the number of bags. So they wrote their equation as P equals 8 times B. Okay, let's take a look at example 2. In example 2 it says, the relationship in the table represents a function. Write a function rule. So define the variables. Okay, so I'm going to say that x is the number of hours, or actually let's use the variables they used. So they used, so scratch that. They used h is the number of hours, and c is the cost to repair a car. So now we're going to relate it. The cost increases $25 per hour. So it's $25 each hour. And then there's an additional cost of $40. So just to take your car in, they're going to charge you $40. So I'm going to put plus $40. And since C was the total cost, then I'm going to set this equal to C. So now I have my equation. Okay, in example 3 says the table models a function relating time of day and temperature. And they want us to identify the independent and the dependent variable. Okay, so dependent variable is what is the change. In this case, the change is time. Normally, anytime you have a word problem that deals with time, time is going to be the independent variable because we don't we can't change time. Time is always changing. So our independent variable is going to be the time, and then the dependent variable is going to be the temperature. Okay, so now it says first define the dependent variable. So what is depending on what? The temperature is depending on the time of day. So that's why we say that the temperature is the dependent quantity, because it depends on what time of day we're looking at. Therefore, the time of day is the independent variable. And like I mentioned before, time is normally the independent if that's one of the variables in the word problem that we're dealing with. Okay, in example 4, Freddie downloads a song for 50 cents. He has $20 to spend on songs. Identify the independent and the dependent variables and find the reasonable domain and range. Now domain and range are new words for us. Domain means all the values that x can be. So if that's what domain is, what do you think range is? Of course, all the values that y can be. So our range is all the, and I'm just going to write ditto, the little thingy, all the values that y can be. Okay, so here, the dependent variable, so what is changing here? Here, the songs are changing and it's affecting the price. So the dependent variable is the songs. I'm sorry, is the cost. I messed up. Scratch that. I thought I read independent. Is the would be the cost or the money spent. And he only has $20 to spend, so they want us to give a reasonable range. Since the dependent variable is always your y and the independent is always your x, think about a reasonable domain. So what are some values that he can spend? Well, since y is the cost, he can only spend up to $20. And obviously you can't spend negative money. So a reasonable range would be from $0 to $20. Now for the independent variable is the number of songs that he can buy. And to figure out a reasonable domain, or what values x can be, we would need to sort of do a little bit of math. Because if it's 50 cents for each song, then he only has $20, then he can only buy 40 songs if he uses up all his money. So a reasonable domain would be from 0 songs, he can buy no songs, or all the way up to 40 songs. Those are values that make sense in this particular equation and word problem that x can be, which is in this case the number of songs. And that's it.